Okay, so let's talk about volume, mass, and density. Have you learned about density before, class? Yes. Okay. Give me the formula for density. Can you see my screen? Am I showing you my screen correctly? Yes. Okay. Give me the formula for density. Anyone remember what's the formula for density? Yes. Thank you. So I'm sure you've learned this before, but it's again in the year 10 book. So we're just going to go through very briefly about calculating density using mass and volume, because even in the IGCSE paper in the past years, right, they still ask, you know, until now, how to determine the density of objects. So let's say, right, we have a stone. Okay, one random object. I'm just going to draw one random object. Random, so circle lah, ha. Random circle object. Let's say this object, we want to determine the density of the material. Okay, so since you've learned density before, that means you know that density of materials are fixed. So it doesn't matter whether you have a lot or a little, the density is the same. So let's say, for example, if this ball is made out of steel, whether it's a big ball or a small ball, because the material is steel, density is the same, no matter what the size is. Because density is the ratio of the mass to the volume. So some of the questions that have come out in the past, right, they ask the students to calculate the density. So experiment-wise, that means experiment, what you need to do is, first of all, you need to get the mass. Now, obviously, even in exam, you have practical exam for certain schools, but I think you won't be taking. If you take the exam, it will all be purely paper, all theoretical. So you have to take a theoretical practical paper. That means the paper is based on experiment, but you answer in theory only. You don't do the experiment in the lab. So you need to know in theory, how to do the experiment. So it kind of helps if you've done the experiment before. That's why I will want you to do some experiments, even though at home, if possible. If you have the materials or the apparatus, then you can just use something from the house, the kitchen curl, or from your own pencil case. Actually, you also can make one. But anyway, let's talk about this one first. So if you want to calculate the density, you must be able to obtain the mass of the object. Tell me, right, if I give you an object like this, a steel ball, how do you measure the mass of this steel ball? What do you use? What do you use to measure the mass of the steel ball? What's the name of the device? Here's the ball. What do you use to measure? Steel yard. What's a steel yard? I want you to measure the mass of. If I give you an object, any random object, I give you a stone also or a book, I want you to measure the mass. Okay, let's try to remember. I don't think you remember. What is the unit for mass? Kg. So how do you measure something to give you kg? You use what? Use a balance, correct. So the balance that you can use nowadays is a digital balance. or you can use the old style triple beam balance. Do you know what this is? Triple beam balance? You don't have also the weighing scale lah, but I think you don't call it weighing scale in your syllabus. You call it you can call it a balance, digital balance. Have you seen a digital balance before? Your kitchen should have lah. If anyone in your family does baking, sure got digital balance. It's not digital balance, then it's the old style scale. That means you put on the dish, then the round face, the thing. I think you all just woke up, is it? You know what these are, right? Okay, like this is a digital balance. Oh, you're all very quiet this morning. 3 of you only, come lah, talk to me. Okay, this is a digital balance. Okay? This is a digital balance. Triple beam balance is this one. This one is a triple beam balance. Okay. If you want to measure the volume, how do we measure the volume of the ball? What can we use? Hey, hello, is anyone there? Am I lagging? Okay, you remember how to measure? If you don't know, also just at least tell me you don't know. Just put IDK also, at least I know you are you are there. If you don't know, it's okay. I'm not expecting you to know the answer. Okay, so if you don't know, just put don't know. All right, it's at least you're letting me know, then I can explain. Okay. Okay, all right. So if you want to measure the volume of the ball, it's like how we use the water displacement method. You remember this method? Oh, by the way, this one has another name. Besides Eureka Can, I double check your book. In your syllabus, sometimes they call it a displacement can because it's water displacement method. So if you want to determine the volume of an object, where like how to measure the volume of a ball, so difficult. Then what you do is you use the water displacement method. So you put it into the measuring cylinder and then you see the difference in the volume. That volume is equal to the volume of the object. So this one, for volume, we will use the water displacement method. Where we will put into the measuring cylinder or a displacement can. I'm going to draw it as a measuring cylinder because a lot of the times in the past years, right, the questions, they will always use a measuring cylinder. So they will put in the measuring cylinder before and after the volume, and then the size is not the same. And then they ask the students, they will just give you the numbers, they give you like that, they give all the numbers, and then they ask the students to figure out the answer. So you see this, like things like this, then you need to know lah. So you need to figure out how to get the number. So this is the volume. Okay. This is the volume of the object. So you take the difference lah. What's the volume? Okay. Then you want to count the density. Then you use the formula to get the density. Okay. Do you know the unit for density, class? Do you know the density or not? Kg per m squared, m2. Okay. MO. What's MO? What's mole? No. Oh, no. Okay. IDK. All right. If you want to figure out units, you can use the formula to figure out. So it's very close, but not 100% correct. So you see, you have density. You told me mass is kg, right? So yes, correct. What about the unit for volume? What is the unit for volume? Is volume meter squared, or something else? Not sure. So how you remember it then, like it's like this. Okay, I will just draw a cuboid, even though it's a sphere, but never mind, we use a cuboid for this example, okay? So the cuboid, you have the length, the width, and the height. Give me the formula. Let's say like, oh, you need to calculate the volume of the cuboid. What's the formula for the volume of the cuboid? If you have to calculate. Cm cube or meter cube. You're giving me the unit for the volume, right? Everyone else know why or not? Why I give you this is because, okay, just give me the formula for calculating the volume of the cuboid. Based on this information, how to get the volume of the cuboid. Okay, length times width times height, L times W times H. So you think like this. Length, what's the unit for length? How, if you measure length, what's the unit? Cm, okay. Width length? Cm also. Height length? Like teacher asking the same question again and again and the same answer. Correct. So why I'm asking this is because this is important for you to be able to understand how to get the units. So a lot of students, they don't understand the units. They like, how must memorize units, then they get very confused. The thing is about units, right, is actually derived from the formula. You see, if volume is length times width times height, length is cm, width is cm, height is cm. Then you think cm times cm times cm. It's actually like that also. Cm 3 times ma, that's why volume is cube. If you use SI unit mass, meters times meters times meters. That's why it's meter cube. That's why you give me cm cube, meter cube is correct. What I'm explaining here is to help you remember what the unit is. So you use the formula to help you remember. And that's why, in this case, if you want to know the density unit, you use the formula as well, mass per volume. So it can become kg per cm cube or kg per meter cube. But normally we don't have kg per cm cube. Normally, okay, it's also gram, right? So normally it's gram per cm cube or kg per meter cube, because mass over volume. If you write the other way, gram per meter cube, kg per cm cube, actually it's not wrong also. Actually can also, it's not wrong. It's just that we don't normally use it. Normally, we don't use it. This one is not common. So when we do questions, you won't see this. So these ones, this is the one we always normally use. Okay. Any questions? Can follow? Okay. Cool. I want us to do some questions. Do you all have you have workbook or not? Not workbook. You have like exercise book, like just a normal line book, or you have test pad paper or not? Do you all have? Got. Okay. I think this is what we will do lah, because for all of you, you don't have the books yet, right? I know it's a bit difficult lah. No books. You don't even have a workbook. So I think what would be a good idea is you create a file for yourself. So if you have an exercise book with the lines and all that, okay, then you take one book and say, okay, this is my physics book, and then all the physics questions we write inside. Do the physics questions inside the book. Or if you have test pad, which is actually maybe a better way, you get a folder. You ask your parents to get you one of those ring folder. Then you write your answer in the test pad. Then you just put it inside your file. Okay. So why I think a file is better than a book is because I'm sure some of you are writing this down already in your notes, right? Then the notes you can also put inside the same file. If you want to use the exercise book, then I suggest you get two. One exercise book for question, one exercise book for notes. Keep the notes and the questions separate. Oh, no, wait, but then you're not handing up to me. So because in school, I always ask them to keep separate. Physical school. Never mind, you can combine lah. No need two lah. Just do one exercise book is enough. You write your notes, then the questions is okay. So what I'm going to do this morning is I'm going to share with you some simple questions from the book. That's my phone. Let me take photo of the question I share. Okay. Here's what I want you to do. I want you to try the questions now. So at least if you don't know, then we can discuss the answer straight away. There's only two questions. So you take out your test pad paper or your exercise book, whichever you're using, and solve the question now. Okay, I want you to try on your own first, instead of me giving you the step-by-step method. Because if you've learned density before, then you should roughly know how to do. If you really cannot and you get stuck, then you straight away tell me, teacher, I don't know how to do. Let's say you don't know how to do question 1, you tell me IDK question 1 or IDK question 2. If both also don't know, then you tell me IDK both question. But never mind, for this morning, you just type your answer in here first lah. Okay. So so give me your answer for question 1, since all of you managed to answer question 1. So which one is the gold? Which one is the silver? Which is a mixture? Okay, so gold is which one? A, B, or C? Okay, so gold, I'll write here the answer. So this is gold. Gold is A. Is that your answer? Did everyone get the same answer? A, silver, B, mixture, C, gold. I'm double checking the answer because I'm like, how come you all got this answer? Okay, you saw wrong. Okay, A, silver, B, mixture, C, gold. Okay. No, it's also not correct. A is gold, A is not gold, A is silver. So can y'all see? You cannot see the color. I cannot see the color. A is silver, yes, but B is not mixture. B is gold, C is mixture. How did you get the answer? Can you just let me know how you managed to get the answer? You divide. So you divide the mass with volume, right? So you must divide the mass with volume and then you compare to these numbers. You compare to these numbers. Then you check. Okay, so you managed to get or not that A is actually 10.5, 10.5 something. Yes. So that's why A is silver. But then B, if you count 3750 divided by 194, do you get 19.3298969072? Well, oh my God, my number is very long. You try and see, you take this number, divide by this, you get 19.3 something. Everyone try now. Right? So you take a divide, that's why you get 19.3. If you take crown C, you get, I think you get 11 point something. Number. You get 11.90. So because it's not gold, it's not silver, but it's in between, that means this is likely that crown C, they took some gold, they took some silver, they mixed. That's why the number is not gold or silver, but it's between, it's in between these two. That's why C is a mixture. Okay? Everyone understand why now? Yes, okay. For question 2, what do you get for, I'm just going to draw a square here so that I got something, a nice place to write. Otherwise, cannot see. Okay, can you give me your answer for 2A? Give me the answer for 2A. What you get? What you get for mass of the liquid? 80 what? Unit, don't forget unit, 80 what? Thank you, 80 grams. How do you get 80 grams? Can you just share? Just share with us how you got the 80 grams. Correct. So guys, you can see why, right? Because here you have the measuring cylinder with the water. Here's the empty measuring cylinder. Then you add water in, So without the water is 90. With the water is 170. So you take this minus 90, you can get the water. I think everyone can get this, right? Volume left. Maybe I write in full so that you can see why. 170 minus 90. You get 100 cm cube for volume. Yes. You can see why, right? Did you also get the same number? Did you manage to get the 100 cm cube as well? Because it's here, right? Okay, good. Okay, how about the density of the liquid? How much you get? Correct. Good job. You took this, right? You divide like that, right? That's how you got the answer. Okay, everyone can understand? How about 2B? Now it's of the stone, of the stone. What is the mass of the stone? $210 grams. How'd you get 210? $290 minus 80. Okay, it's a very good try, but it's not like that. but you must minus. So yes, it's 290 minus something, but it's not minus 80, it's minus 170. Because with the, I know you minus 80 because you minus the water, but you must also minus the measuring cylinder. So if you do that, means you must have 290 minus 90 minus 80. Or a faster way, 290 minus 170. Because 170 is the water and the measuring cylinder. 290 is the stone, the water, and the measuring cylinder. That's why you minus like that. Can understand? Because this one is no stone, this one got stone. So the difference is the mass of the stone. No? So what's the number? 290 minus 170 is how much? Come. You all should be quite good at maths. Give me the number. Okay, thank you. 120 grams. What about the volume of the stone? How to get the volume? Or give me the number. What's the volume? (48 cm cubed). Yes, thank you. So now that you know the mass and the volume, can you give me the density of the stone? Yes, thank you. Correct. So this Jamboard, Jamboard already is in your Gmail, yeah. But like I said, you just log into Google with your Gmail. You go to your Google Drive. You will see the Google Drive, this physics folder there. All this Jamboard is already inside. So I'll be putting all the future Jamboards all in that folder, so that in the future, even if like I said, like, even if let's say outside of class you just want to take a look again, double check, you can go back, just go to the folder anytime and you can see that. Easy to access, no need to just wait for class. I will create a WhatsApp group afterwards for us to share the answers for future work, because physics we need to do a lot of questions. But some questions are easy, some questions are a bit difficult, but you need to do. Otherwise, no point you know how to, I understand, ask you to solve a problem, don't know how to solve, no point right? Solving problems is not just for solving exam. Solving problems also is in the future. If you want to become engineer, innovator, inventor, you need to know how to solve problems using your concepts you learn. Anyway, yeah, so I know I wanted to talk about the experiment, but I think that this is more important. We finish this first. Next week we do the experiment, okay? Next week I go through the experiment. We can do the experiment next week. All right.